Deputy Executive Information Engineers in Andhra Pradesh Information Services, Electronics and Communication Engineering 2019 Question Paper Solutions Part 4, that is from question number 91 to question number 120. First question. A series regulator has an output voltage of 9 volts. If the op-amp closed loop gain is 3, what is the value of reference voltage? Given the output voltage of series voltage regulator V0 is 9 volts. As per the question, V0 is 9 volts and the given closed loop gain is 3. We know that gain is equal to ratio of output voltage to input voltage. So from this, input voltage VA is equal to output voltage by gain, that is 9 by 3. Input voltage is 3 volts. Therefore, reference voltage or input voltage VI is 3 volts. Correct answer is option 3. Question number 92. A low pass Butterworth filter to band pass Butterworth filter transformation will be. In the question, we need to identify the correct transformation for converting low pass Butterworth to band pass Butterworth filter. So transformation for converting normalized low pass to low pass is S is replaced with S by omega C. Low pass to band pass is S is replaced with S square plus omega U omega L divided by S into omega U minus omega L, upper and lower cutoff frequencies. Similarly, low pass to band stop is S is replaced with S into omega U minus omega L divided by S square plus omega U plus omega L, lower and upper cutoff frequencies. So the correct answer is option 4. Low pass Butterworth to band pass. Correct answer is option 4. Question number 93. 5.5 equal point charges having a charge 20 nanocoulombs. Given charge is 20 nanocoulombs and the charges are located at a distance of 2 meter, 3 meter, 4 meter, 5 meter and 6 meter. The potential at the origin is, we know that potential V is equal to sigma I is equal to 1 to m number of charges q divided by 4 pi epsilon naught Ri. Ri is a distance from the corresponding charge to the center. So charge q is 20 into 10 power 9 divided by 4 pi. Epsilon naught value is 8.854 into 10 power minus 12. Sigma n is equal to 125 1 by Ri. So here sigma I is equal to 125 1 by Ri. It can be written as 20 into 10 power minus 9 divided by 4 pi into 8.854 into 10 power minus 12, 1 by 2, 1 by 3, 1 by 4, 1 by 5 plus 1 by 6. By 6. So on calculation, its value is 179.75 into its value is 1.45. Therefore, final answer is 260.64 volts. So correct answer is 261 volts. Question 94. Pulse width modulation involves. So we know that pulse width modulation or pulse duration modulation, the width or duration of periodic pulse train is varied in accordance with the instantaneous value of message signal. From the given options, correct answer is option 1. Varying the width of pulses in the periodic pulse train according to the instantaneous variations of message signal. Similarly, pulse amplitude modulation is the amplitude of periodic pulse train is varied in accordance with the instantaneous value of message signal. Pulse position modulation is the position of periodic pulse train is varied in accordance with the instantaneous value of message signal. Question number 95. A conductor of length dash normal to the infinite conducting plane forms a monopole antenna. A conductor of length L by 2 normal to an infinite conducting plane forms a monopole antenna where L is the length of dipole. L is length of dipole or dipole length, that is lambda by 2. So L is replaced with lambda by 2 divided by 2. Its value is lambda by 4. A conductor of length lambda by 4 normal to an infinite conducting plane forms a monopole antenna. This is because a monopole antenna is essentially a half of the dipole antenna, and the conducting plane acts as a mirror, making the effective length appear as lambda by 2. Monopole antenna is typically a quarter wavelength lambda by 4 conductor mounted perpendicularly over a perfectly conducting ground plane. Its physical length is lambda by 4, effective wavelength is lambda by 2. Due to image in the conducting plane, function works like a dipole but with a single conductor over a ground plane. Next question. The advantage of linear regulator is. The main advantages of linear regulator are low output noise and ripple, simple design, fast transient response, low cost, excellent line regulation as well as excellent load regulation, and no electromagnetic interference issues. Correct answer is option 2, accuracy of the control. This linear regulator maintain precise and stable output voltage with little deviation under varying load and input conditions, which is a key benefit over switching regulators. Next question. The differential equation of SISO system, single input single output system, is given by d square y by dt square plus 2 dy by dt plus 10y is equal to 5 du by dt minus 3u, where y denotes the output and u represents the input. For an input u of t with 0 initial conditions, the above system produces the same output as with no output with initial conditions. Y dash of 0 is minus 4, y of 0 is 1. In the given question, differential equation is given d square y by dt square plus 2 dy by dt plus 10y is equal to 5 du by dt minus 3u. Also given the input also given the condition with 0 initial conditions, the above system produces same output as with no input, that is 0 input having the initial conditions. So first we need to find the output of the system. The output of the system for input u of t with 0 initial conditions. We will apply Laplace transform to the given differential equation, and on solving we will get y of s is 5s minus 3 divided by s square plus 2s plus 10 into u of s. Similarly, system output for 0 input having initial conditions. On solving we will get y of s is s minus 2 divided by s square plus 2s plus 10. Also given in the question, the output of the system for input with 0 initial conditions is same as the output of the system for 0 input having the initial conditions taken into consideration. So this equation 1 and equation 2 are same as per the given questions. So equating the above two equations, so we will have u of s is 1 by 5 minus 7 by 5 into 1 by 5s minus 3. Apply inverse Laplace transform, we will get this u of t is equal to, on applying inverse Laplace transform, we will get u of t is equal to 1 by 5 delta of t minus 7 by 25 e power minus 3 by 5 into t u of t. This is the final answer, u of t. Therefore, correct answer is option 2, 1 by 5 delta of t minus 7 by 25 e power 3 by 5 into t u of t. Question number 95. In the feedback system shown in the figure below, the time constant of closed loop system will be. So given open loop transfer function g of s is a by 1 plus st, and h of s feedback transfer function, it is given as beta. Feedback transfer function is beta. Now the closed loop transfer function is c of s by r of s is g of s by 1 plus g of s h of s. G of s is a by 1 plus st, 1 plus a by 1 plus st into beta. On solving, we will have a by 1 plus s tau by 1 plus a beta. And the given system is first order system with time constant tau dash is tau by 1 plus a beta, where tau is a time constant of open loop transfer function and beta is the feedback loop gain. The time constant of closed loop system will be tau dash is tau by 1 plus a beta. Correct answer is option 4. Next question. The ability of receiver to select the wanted signal among the various incoming signals is termed as. So selectivity. Correct answer is selectivity. Receiver selectivity is the ability of receiver to isolate and process the desired signal while rejecting unwanted signals that are close in frequency. This selectivity determines how well a receiver can distinguish between signals on adjacent channels. High selectivity means better rejection of nearby interfering signals. The ability of a receiver to reject unwanted components and select the desired components is selectivity. Similarly, the definition for receiver sensitivity is minimum signal strength that the receiver can able to detect and process accurately is sensitivity. Lower sensitivity value, more negative value indicates better sensitivity, and this sensitivity determines how well receiver performs with weak signals. Sensitivity affects range and reliability of the communications. So for the question, the correct answer is selectivity. Next question, question number 100. The Boolean expression of the figure shown below is. So let us assume P is the output of NOR gate 1, Q is the output of NAND gate, this is NAND gate 2. 1 is NOR gate, 2 is NAND gate, and 3 is NAND gate again. So P is NOR of x plus y. NOR of x plus y is written as a plus b whole bar, that is a bar dot b bar. Q is NAND of p comma z, that is pz whole bar, p bar plus z bar. So p is a plus b whole bar, p bar is a plus b whole bar plus z bar. It can be written as a plus b plus z bar. Now output Output is Q dot W whole bar, that is Q bar plus W bar. So it can be written as A plus B plus Z bar whole bar plus W bar, that is A bar dot B bar into Z plus W bar. Output is, so here A B, so it can be written as X bar Y bar dot Z plus W bar. Correct answer is option 2. Number 101. The transmitted signal in a GSM system is of 200 kHz bandwidth and 8 users share common bandwidth using TDMA. If at a given time 12 users are talking in a cell, the total bandwidth of the signal received by the base station of the cell will be at least in kilohertz is given. Bandwidth per carrier is 200 kilohertz. Bandwidth per carrier is 200 kilohertz and 8 users share a common bandwidth using TDMA. In GSM global system for mobile communications with TDMA, 8 users share single 200 kilohertz channel. In the question they have given 12 users active at a time. Therefore number of carriers needed is 2. The total bandwidth is number of carriers into 2 and bandwidth of each carrier is 200 kilohertz. So the correct answer is 400 kilohertz, option 4. Next question, if A is equal to 2ax plus 4ay minus 3az and B is ax minus ay, then curl of a comma b, a cross b is, so a cross b is given as modulus of ax ay az and second row is 2 4 minus 3, third row is 1 minus 1 comma 0. On solving we have ax component coefficient is minus 3, ay component coefficient is plus 3 plus az minus 2 minus 4, that is minus 3 ax plus 3, so this is minus ay. Minus 3ay minus 6az. Correct answer is option 2. Question number 103. Consider the following statements. The amplitude of FM wave is constant. So statement 1 is correct. FM is more immune to noise than amplitude modulation. Statement 2 is correct. FM broadcast operate in upper very high frequency and ultra high frequency ranges. So FM broadcast operate in upper high very high frequency and ultra high frequency range. So generally FM station operates at 98 to 108 megahertz. So VHF frequency range is from 30 to 300 megahertz and ultra high frequency is 300 megahertz to 3 gigahertz. So statement 3 is correct. Statement 4, FM transmitting and receiving equipment are simpler as compared to AM transmitting and receiving equipment. Statement 4 is incorrect. Therefore correct answer is option 1. Statement 1, 2, 3 are correct. FM transmitter and receiver are more complex. It is not simpler. It is more complex than AM transmitting and receiving equipments. Next question. The buried layer is a heavily doped N plus layer sandwiched between the P-type substrate and N-type epitaxial collector to dash the collected series resistance of IC transistor to reduce. The buried layer is heavily doped N plus region It is located between p-type substrate and n-type epitaxial layer. So correct answer is to decrease the collector series resistance of IC transistor. This N plus buried layer has very low resistivity due to high conductivity. Current flowing through the collector can bypass much of the high resistivity epitaxial region by traveling laterally in low resistance buried layer before reaching the collector contact. This effectively reduces series resistance of the collector path. Because of this buried layer, frequency response is improved. It reduces the heat generation in the collector path. It helps to achieve better performance in high speed circuits. Correct answer is option 1. The buried layer is a heavily doped N plus layer sandwiched between P type substrate and N type epitaxial collector to reduce the collector series resistance of IC transistor. Next question. Consider the system represented by x dash is equal to ax plus bu, where A is system matrix and matrix is A is equal to 0 5 0 0 and B is 1 0. The associated state transition matrix is given system matrix A and input matrix B. State transition matrix phi of t is equal to e power at, and this e power at can be written as I plus at plus 1 by 2 factorial a square plus t square and so on. So we know a square is 0. So from this a square is 0. E power at will become e power at will become I plus at, where I is identity matrix. This e power at is state transition matrix. So on solving, phi of t is equal to e power at is equal to I plus at. I is identity matrix 1001 plus A matrix is 0500 into t. 1 plus phi t 0 1 is phi of t. So this phi of t is 1 plus phi t 0 1. Correct answer is option 3. Question number 106. The first order dynamic system is represented by a differential equation 5x dash of t plus x of t is equal to u of t. The corresponding transfer function and state space representation are: let x of t be the state variable. On rearranging the original equation, we will have 5 into x dash of t is equal to u of t minus x of t. Take this x of t to the right hand side, that is x dash of t is equal to minus 1 by 5 x of t plus 1 by 5 into u of t, rearranging this given equation, and apply Laplace transform. We will have d by x dash of t is d by dt of x of t. So applying Laplace transform, d by dt will represent s into x of s minus 1 by 5 x of s plus 1 by 5 u of s. From this, x of s by u of s is 0.2 divided by s plus 0.2, 1 by 1 plus 5s. So transfer function is 1 by 1 plus 5s. So in option 2, this is transfer function is incorrect. For option 3, transfer function is incorrect. For option 4, transfer function is incorrect. Therefore, correct answer is option 1. And state equation is x dash of t is equal to minus 1 by 5 x of t plus 1 by 5 into u of t. Now the output equation is y of t is equal to x of t. In matrix form, x dash is equal to ax plus bu, y is equal to cx plus du, where A is state matrix, B is input matrix, C is output matrix, and D is feed forward matrix. On comparison, we will have this x dash and y of t. We will have A is equal to minus 1 by 5, B is 1 by 5, C is 1, D is equal to 0. So compare these two equations with this, we will get A, B, C, D values. Here the correct answer is option 1. Next question. A two-port network is reciprocal if and only if the condition for two-port network to be reciprocal is Z12 is equal to Z21, Y12 is equal to Y21, AD minus BC is equal to 1, A dash D dash minus B dash C dash is equal to 1, H12 is equal to minus H21, G12 is equal to minus G21. In the given options, correct answer is AD minus BC is equal to 1, that is BC minus AD is equal to minus 1. Next question. How many complex multiplications are necessary in a radix 3 decimation in frequency FFT computations? The total number of complex multiplications required is 2n by 3 log base 3 n. Correct answer is option 2. Similarly, in the question complex multiplications is 2n by 3 log base 3 n. Similarly, the general formula for finding the complex additions in radix R FFT is R minus 1 into n log n base R. Here in the question R value is 3, that is 2n log n base 3. 2n log n base 3 is for complex additions and 2n by 3 log n base 3 is for complex multiplications. Correct answer option 2. Next question. Consider the following single loop feedback structure illustrating the return difference. The return difference A is. So in control theory and signal processing, the return difference is defined as 1 plus A beta, where A is forward gain, beta is a feedback factor. So correct answer is option 4. So return difference formula is f of a is equal to 1 plus a into f suffix a, where f suffix a is feedback path gain and a is forward path gain. So in the question, forward path gain is from x1 to x2 and feedback gain is from x2 to x3, x3 to. So from this product is a into f of a represents loop gain. If this f of a return difference formula, if this return difference is equal to 0, the system is at stability boundary. If f of a return difference is greater than 0, negative feedback. If it is less than 0, positive feedback, destabilizing. Correct answer option 4. Question number 110. Which statement is wrong for the general rules that should be considered when using heat sinks? So statement 1, do not block airflow around the heat sinks. This statement is correct. In the question they ask you to find the wrong statement. Statement 1 is correct. Use insulator to prevent heat sink. This is also correct. Use heat sink appropriate for target power dissipation. Correct. Give excessive torque on the mounting hardware. This statement is incorrect as per the question. Wrong statement is option 4. General rules for using heat sink are: maximize the surface area, ensure good thermal contact, orient fins properly, avoid obstructing airflow, use appropriate materials, avoid electrical short circuits, ensure proper mounting, optimize the airflow. So general rules that should be considered when using heat sink are: do not block airflow around the heat sink, use insulator to prevent the heat sink, use a heat sink appropriate for target power dissipation. Next question. Consider two silicon PN junction diodes, one is long and one short, contacts within a diffusion length of the depletion region but otherwise identical. Under identical forward bias voltage, which diode would have greater current flow? Given two identical silicon PN junction diodes of different lengths, the current flow in shorter diode is more compared to the longer length diode. Shorter diode current is greater because minority carriers are extracted more efficiently and steeper carrier concentration gradient near the depletion region drives higher diffusion constant. So correct answer is 2. Shorter diode have more current flow, greater current flow compared to long length diode. Next question. Question number 112. The consensus theorem states that. So consensus theorem is used to eliminate redundant term. It is applicable only if Boolean function contains three variables. Each variable is used twice. Only one variable is in complemented and uncomplemented form. Then the related terms to a complemented or uncomplemented variable is the answer. So take the expression, it contains only three variables x, y, z. Each variable is used twice. So here x is used, x bar, y, y, z, z. Each variable is used twice and only one variable is in complemented and uncomplemented form. So either x is in complemented form and remaining two variables are repeated twice, y, y and z, z. So correct answer is option 1. So option 1 contains three variables x by x bar z plus yz. Only one variable is in complemented uncomplemented form x bar, that is ab a bar c plus bc. Now for this expression, the related terms to the complemented and uncomplemented variable is the answer. The related terms with x is the answer, that is xy x bar z is the answer. Dual of consensus theorem. So correct answer is either this one or this one. So correct answer is option 1 as per consensus theorem's conditions. Question number 113. A capacitor of 0.1 farad has a leakage resistance of 100 kilo ohm across its terminals. So given capacitance is 0.1 farad, resistance is 100 kilo ohms. The quality factor at 10 radian per second is. So for series RLC circuit, quality factor is given as Q is equal to omega L by R 1 by omega RC or 1 by R root L by C, that is 1 by omega is 10 radian per second, given omega is 10 radians per second and resistance is 100 kilo, capacitance is 0.1. So quality factor is 10 power minus 5 for series RLC circuit. So 10 power 5 is not in the answer. So next see, for parallel RC circuit, quality factor for parallel RLC circuit, quality factor Q is equal to R by omega L, omega RC, R into root of C by L. So omega is 10, resistance is 10 kilo ohms, 10 into resistance R is 100 kilo ohm, 100 into 10 cube and capacitance C is 0.1. Now the quality factor Q is 10 power 5. So for parallel RLC circuit, quality factor Q is 10 power 5. For series RLC circuit, quality factor Q is 10 power minus 5. In the question, they haven't mentioned either it is series RLC circuit or parallel RLC circuit. It is not mentioned in the question. So we need to assume it as parallel RLC circuit. According to parallel RLC circuit assumption, quality factor Q is 10 power 5. Next question. An 8-bit successive approximation analog to digital converter has a full scale reading of 2.55 volts and its conversion time for analog input of 1 volt is 20 microsecond. What is the conversion time for 2 volt input. For one for analog input of 1 volt, conversion time is 20 microsecond, and the conversion time for 2 volts is also 20 microseconds. So because in n bit successive approximation digital to analog converter, conversion time is independent of input voltage magnitude. Correct answer is option 1. Next question. Amplifier has a power gain of 23 dB. If the input is 1 milliwatt, what is the output? So given power gain is 23 dB, input voltage is 1 milliwatt, we need to calculate the output voltage, that is 10 log of 10 log of P out divided by P in 10 power minus 3 is equal to 23 log of P out divided by 10 power minus 3 is 2.3. So from this, P out is equal to 10 power minus 3 into 10 power 2.3, 199.5 milliwatt. Correct answer is option 1. Next question. For a particular case of amplitude modulation using sinusoidal amplitude wave, the percentage modulation is 20%. The average power in the carrier signal is. In the given question, amplitude modulation with modulation index mu is 20%. So 20% is the modulation index, that is 0.2. Now power in side bands, PSB is equal to PC into mu square by 2. Carrier power is PC, mu square is 0.2 whole square by 2, that is 0.02 PC. So it can be written as power in sideband is 2% of total power. Now total power PT is equal to PC into 1 plus mu square by 2, PC plus PC mu square by 2, that is carrier power plus sideband power. If sidebands contains 2% of total power, then carrier contains 98% of total transmitted power. Correct answer is option 1. Next question. A 1 centimeter radius circular loop antenna has n turns and operated 100 megahertz. If the radiation resistance is 10 ohms, then what is the value of n? And the given antenna is circular loop antenna. Given antenna is circular loop antenna. Radius is 1 centimeter, that is 0.01 meters. Frequency 100 megahertz. Radiation resistance 10 ohms. We need to calculate the number of turns. So once frequency is given, then wavelength is calculated as lambda is equal to C by F, 3 into 10 power 8 by 100 into 10 power 6, that is lambda wavelength is 3 meters. Wavelength is 3 meters and loop circumference is 2 pi r, 2 pi a is the radius, 2 pi into 10 power minus 2, that is 0.0628 meters. Once wavelength and circumference is calculated, here wavelength is far greater than circumference. So when this is a condition, this is a small loop condition. Radiation resistance for small loop antenna is given as 20 pi square n square C by lambda into whole power 4, where radiation resistance is 10, 20 pi square, we need to calculate the number of turns, and circumference is 0.0628 by 3 whole power 4. On calculation, we will get the number of turns is 513.67 tons. So it is 515. Approximate answer is 515 tons. First we need to calculate wavelength, then circumference. Then based on this wavelength and circumference, we need to identify whether it is a small loop antenna or large loop antenna. So here circumference is far less than wavelength. It is a small loop condition. For small loop condition, radiation resistance is 20 pi square n square c by lambda power 4. And solving, we need to obtain the value of n. Notice the radiation resistance formula for small loop antenna of radius a having n number of turns operating at wavelength r is 31200 Na by lambda square whole square, where A is area of loop. This is a one more formula to calculating the radiation resistance for small loop antenna. Next question. A system has input output relation given by y of t is equal to t into x of t, that is x square of t. Then the system is, so given y of t is x square of t. So given y of t is x square of t, output due to input x1 of t, that is y1 of t is equal to x1 square of t, y2 of t is equal to x2 square of t. The sum of outputs is y of t is equal to y1 of t plus y2 of t, that is x1 of t, x1 square of t plus x2 square of t. Output due to x1 of t plus x2 of t is, so that is x1 square x2 square plus 2 into x1 plus x2. So here the output due to sum of inputs is not same as sum of outputs due to input. Hence the system is non-linear system. So the given system is non-linear, and then we need to identify whether the system is time invariant or time variant. A system is said to be time invariant if its input output characteristics does not change with time. So let us find output due to delayed input, that is x square of t minus t naught, and then delayed output y of t minus t naught is equal to x square of t minus t naught. The output due to delayed input is same as delayed output, hence it is a time invariant system. In the question, the given system x square of t is non-linear time invariant system. So non-linear time invariant system. Question number 119. A polynomial is given 2s cube plus 2s square plus s plus 1, and we need to find the roots of the given polynomial. So using RH criterion, we will write s cube corresponding coefficients are 2, 1 for s square row 2, 1, and this for s power 1 row of 0 condition will occurs. If row of 0 condition will occurs, auxiliary equation is, so here it is 2 minus 2 by 2, that is 0, row of 0 condition will occur. Then we need to calculate the auxiliary equation. So from this auxiliary equation, the coefficient of s power 1 is 4. So if it is 4 and the coefficient of s power 0 is 4 into 1 minus 2 into 0 by 4, its value is 1. The auxiliary equation roots are 2s square plus 1 is equal to 0. From this, s is equal to plus or minus j 1 by root 2. Now plus or minus j 1 by root 2, these are the two roots, and the third root we need to calculate. The roots of auxiliary equation are the roots of the characteristic equation. Using this condition, s plus j 1 by root 2, s into s minus j by root 2 into s plus pi. We need to calculate this root pi. So on solving, we will get pi is minus 1. Only the value of pi is equal to minus 1 satisfies the given characteristic equation. Therefore the roots of given polynomial are minus 1, plus or minus j 1 by root 2. So here option 1, option 4 plus or minus j 1 by root 2 is here. Then we need to find the third root, whether it is minus 1 or plus 1. It is minus 1, so option 4 is not a correct answer. Question number 120. The bandwidth of DSB suppressor carrier modulation system, double sideband suppressor carrier modulation system, when the modulating frequency varies between 500 Hz to 5 kHz is. Given frequency range is 500 Hz to 5 kHz, 5000 Hz. The bandwidth of DSB-SC signal is 2 into FM, where FM is the highest frequency component of message signal. That is 2 into highest frequency component of message signal is 5000 Hz. So that is 10 kilohertz. So nearest answer is option 4.